advantage of the remote operations capabilities that sit in Australia, bring those capabilities from industry together with academia, together with the space industry as well, was also building out a remote operating centre for deep sea that they then converted to enable to operate lunar missions as well, with additional focus on building out, the future workforce so that this could continue to grow into the future for Australia to build out Australian sovereign capability.
Welcome to the Omar Al-Aili podcast, your go-to podcast for exploring the diverse fields driving space exploration and technology. I'm your host, Omar Al-Aili, and today I'm thrilled to be joined by Michelle Keegan, a visionary leader who has spent years at the crossroad of terrestrial and space mining, notably as the former Director of Resource and Space at AROSE, the Australian Remote Operations for Space and Earth, and also the AROSE Program Director for the Australian First Lunar Rover. Michelle, welcome to the podcast.
Thank you. It's exciting to be here. Thanks for the opportunity.
Likewise. Michelle, how did your extensive experience leading the next generation mining innovation program at South 32 shape your approach to navigating the interdisciplinary cross between mining and space?
It's a great question. I spent a few years at South 32 really with a mission to create the next generation mine blueprint for that company. So they had, really looked at the future of the business being in base metals, and largely it was underground. And in order to do that, they wanted to make sure that each one of the new projects that they stood up really did represent a modern mine. And so my work there was really trying to understand from thought leaders, right across the globe, and including within technology providers, what could that mean and what should that mean, and how would we build that into the program? So I guess that really stretched my mind across a number of different areas, from ore body knowledge through to processing, through to extraction, energy, and then how to stand up a project in a different way through digital project delivery methods. And I guess I didn't really realise until after I'd finished just how that could possibly shape rethinking that even further by thinking about what if this operation was on the moon or some further remote planetary body, and therefore what else would change? And so coming to AROSE, my opportunity was to think about all of this learning, to think about what could be even better, or what could be even better if the connection with the space industry could help solve for some of the challenges in creating that next-gen blueprint. So it really was at the leading edge of some of the technology development for these new projects at South 32. But we didn't want to look at a blue sky mine. We wanted to look at what was a modern mine and what were some of the technologies or design opportunities that were emerging that we should absolutely kind of build in and provide optionality for. So coming from there to AROSE, I didn't realise how easy the transition would be until I got to AROSE and started to think about what next.
Great. So AROSE has this incredibly ambitious mission to position Australia as a global leader in remote operations, not just here on Earth, but out in the extreme environment of space. For many of our listeners, the idea of an organization acting as a direct bridge between the often gritty, down-to-earth world of mining and the high-tech, almost ethereal realm of space exploration might seem quite novel. Could you illuminate for us why this convergence is not just innovative, but absolutely critical in this current era of accelerating space activity?
It's really interesting, and I think there are many people around the globe that haven't heard of some of the large miners that we have in Western Australia. But when Pamela Melroy, the former Deputy Administrator of NASA, was out in Western Australia around 2017-18, as the Space Agency was being created, she spent some time up in the northwest of Western Australia, and she saw just what happened every day with the large iron ore miners, which is largely about remote operations. So if you look at what happens there today, Western Australia actually provides 40% of the world's iron ore. It's the largest global producer when you put together the companies collectively. They move 1 billion tonnes a year of iron ore today, which is about 4 times larger than at the beginning of the boom, prior to this level of automation being employed. And so operating from around 16, 17, 1800 kilometres away from Perth, there are large remote operating centres that actually enable this. They have a small number of people operating a large number of assets up north. If you think about a number of mines, would be over 20 mines that are operated from these different operating centres, and they're stood up to both run automated trucks, trains, drills, but also enable the remote operation of plants, of ship loaders, and a number of activities up and down the value chain.
Mm-hmm.
And when Pam Morrow went up to the operations there, her comment was, if you could do this every day on Earth at this kind of scale, surely it'd be a piece of cake on the moon. And so I guess that's really where the idea was formed, to create an organisation like AROSE. At about the same time, Fugro was also building out a remote operating centre for deep sea that they then converted to enable to operate lunar missions as well. And that is probably, or arguably, the most modern operating centre. So beyond what Rio Tinto and BHP and Fortescue now run, which have been in place for over 15 years, but running very successfully. And so I guess it was kind of her insight into these remote and very harsh environments. I mean, in the open pit, there is kind of plus 50 degrees at the beginning of the boom. I guess the mining companies realised they wouldn't be able to reach the level of growth needed by continuing to operate, with people in traditional ways. The only way that Western Australia is now the largest producer of iron ore is because of this level of automation, which both enables a safe operation but also a very productive operation. And so these are the skills which we firmly believe, and Pam Mulroy identified as skills that we could take to future lunar missions or missions beyond lunar surface as well.
Okay, great. Let me follow up on this. What was the fundamental challenge or opportunity that AROSE was established to seize upon?
Yeah, so AROSE is really established to be able to take the large challenges that we face in the mining or resources sector, i.e., including energy as well, and solve that in different ways. To be able to take advantage of the remote operations capabilities that sit in Australia, bring those capabilities from industry together with academia, together with the space industry as well, and effectively bring together a number of capabilities that could facilitate going after space missions. And so the organisation, really was stood up to be able to do that. And, at the time there were 5 founding members across energy, academia and mining. And it's kind of continued to grow from there with additional focus on building up, the future workforce so that this could continue to grow into the future for Australia to build out Australian sovereign capability as well.
Great. So one of AROSE's most high-profile endeavors and the project where you served as program director is Australia's first lunar rover, part of the Trailblazer program. It's about collecting lunar regolith for NASA, a tangible step towards understanding off-world resources. So beyond the sheer wow factor of Australian rover on the moon, what does this mission truly signify for Australia's evolving identity as a spacefaring nation?
Yes. Yeah. Well, I think, Australia is one of the early countries to sign on to the Artemis Accord. And as part of that, the Lunar Rover was identified as the contribution to that accord. And this was really about trying to harness what we're great at, which is the remote operations capability. So could we actually establish a foundational services capability, for the nation by bringing together people from right across the nation, across every state, across multiple industries, to be able to use that focal point of a lunar rover to do that. And so the Australian Space Agency, funded the initiative and so partly funded the program that AROSE was part of in stage 1 in parallel to the other consortium, ELO, which is now moving forward with the design and to build. But it's really important for AROSE and the members, and the key members leading that were Fugro and Nova Systems, but there are a number of other organisations underpinning that as well. There's a number of ex-NASA and ESA and other people from around the globe that were attracted into the team to do that from those member organisations.
Mm-hmm.
And so you really started to see this capability build in Australia, which was really important to continue to transfer knowledge to local people right across the country as well. And so, this capability transfer still, continues to survive inside Australia as a result of what we did. And what was really exciting was the project manager who had, many missions under her belt, Dawn McIntosh from Fulgro, and the chief engineer, Sarah Cannard from Nova Systems, and then the rest of the technical team behind that. So it was a great initiative in many respects, including the design, the capability build, and the future workforce capability build, which we did a lot of work on as well.
Okay, and how do you even begin to translate the hard-won expertise from remote operating, say, a colossal automated mining truck in the harsh Pilbara to designing and managing a sophisticated vehicle that has to survive and function on the moon?
Mm. Yeah, and I mean, you can't underestimate the technical knowledge of the team, the
Mm-hmm.
technical team that were doing the design and bringing every other mission experience that they had from many years. But what we did, or I guess my role was also to try to bring the resources sector to the table. So we stood up a resources advisory board, and that included almost a dozen people with various sets of experiences across large tier 1 miners, tier 2 miners, technology companies, for the purpose of trying to bring their knowledge into reviewing whether it was a risk assessment or some of the other standards, reviewing the concept of operations and the design of the rover, right through the journey of that design. So we were really excited to be able to do that because, one, it brought in a different set of experiences and knowledge and that design, but also there was opportunity for the two-way transfer back to the mining companies, just in how to go about mission design to bring that systems engineering approach to life, for mining companies into the future from the knowledge gain. So everything from, setting the goals and objectives through to the concept of operations and, all the way through to that preliminary design, of which all, personally believe can be completely applied directly into mining, particularly as we start to think about new frontiers that we haven't operated in continuously, like very deep mining. So great opportunity, not just to contribute to the Lunar Rover, but
Mm-hmm.
to other capabilities in the future for the resources sector.
Great. Michelle, you also spearheaded initiatives described as mining missions to NASA, especially taking Australia's mining and METS sector expertise directly to the doorstep of the world's leading space agency to help accelerate their plans for sustainable off-world living. When you facilitate these dialogues, what specific Australian capabilities, perhaps in automation, AI, or specialized drilling, tend to generate the most excitement or surprise from NASA's seasoned engineers?
Yeah, and I think the surprise is actually much wider than anyone would have thought. So, I was lucky to meet John Stock, who was at the time at the USGS and then was transferring into NASA. And, he really saw that there was an enormous opportunity largely around exploration. So with NASA's, really lofty goals within the Moon to Mars strategy,
Mm-hmm.
a key aspect of that is to be able to explore and understand much more about what sits below the subsurface of the moon. And
Mm-hmm.
so with new technology, new approaches, new thinking being needed to do that, he saw that overlap with what is needed in the critical minerals kind of supply chain that we need to fill now to support the energy transition. And so knowing that we need to unlock, many new mines into the future to support that energy transition, he recognised that there is very different ways that need to be approached on Earth to achieve that. And so when he saw some of the thinking and work I'd done at South32 and then, was starting to bring the different capabilities into AROSE, he was really keen to see how could we bring more of the sector from Australia, to the table to be able to
Okay.
talk to not just our experiences, our decades of experience in exploration, but also how we then start to think about, once we've defined a resource or that ore body below the surface, then how would we think about the design for extraction of that and processing of that, or the different trade-offs that are required in designing all of that infrastructure. But also, how do we think about some of the challenges and trends that we're all facing now, which is to achieve this with a much smaller footprint, and knowing kind of, the depth of the ore bodies that we need to explore into the future. So, we started with exploration 2 years ago. And so I guess I just leveraged the network that I had in Australia to bring, some of the best miners and technology companies to the table. What NASA and many of the others from the space industry saw is just the depth of experience that we had, but also the depth of potential in the overlap. And hence, moving from last year, where we had around 20 people from large tier 1 miners to mining tech companies, to this year, where I was able to bring together around 20 different companies, not just from Australia, but also around the globe. So there were other companies from the United States and from Canada. So with over 150 people all up in the room across the two sectors, we were able to come to the table with, here's what we do, here's why we do it, and here's where we need help to move forward. And so between those 2 years, we've also had some of the team from NASA out to Australia to actually go and visit the remote operating centres, to actually go and visit some of the remote operations. And for them, actually being immersed into the remote operating centre to understand why we design the way we do, but also to be immersed inside these very large-scale operations. While that may not represent exactly what will happen on the lunar surface, they could still see the many challenges and trade-offs required in designing the infrastructure that is needed to do everything, to be able to go from exploration through to ultimately a product that is built and designed to serve the various different customers, whether it's on Earth or whether it's kind of on the lunar surface. So it's you kind of realize that once you have these focal points around exploration and then autonomy this year, you start to give a point of reason for people to come together and want to design, want to start to get to the level of detail that is absolutely needed to support future collaborations. And so out of the discussions this year, there are many different collaborations that are starting to occur outside, both with some of the METS companies that are now looking to look at lunar operations, but equally between mining companies and METS companies, just directly, just from the different thinking they've had from the space sector. I guess the other interesting thing I observed there is you have, some companies that are looking to establish, different, I guess, business models on the lunar surface. And so without having designed and built infrastructure there before, it really did kind of ring true as to the need to bring some of what we have in the mining sector to the table, hopefully to help fast track some of their design, hopefully to help remove some of the pain or the learnings that we've gone through, and to also contribute to ongoing to the architecture in place.
Fascinating. So let's flip the table now. What's a common light bulb moment for Australian mining veterans when they fully grasp the unique, almost mind-bending constraints and requirements of operating in space?
I probably kind of move to the example of deep underground mining. So if we look at the ore bodies that have been found over the last 100 years in the copper industry, most of these have been found at the surface. They've been mined for many decades at the surface, but discoveries that are being found today are much deeper, so 1,000, 2,000 metres. And, while this isn't uncommon in places like South Africa, for other places around the globe, this is going to become more and more common just to be able to satisfy mineral needs. And so when you start to look at that, the deep underground mining environment in a GPS denied area, very hot, it's plus 90 degrees. It's not the same temperature extremes as the moon, but it still is temperature extreme, which means it's going to be hard for people to go down there, which then also means going to a level of automation and electrification with kind of zero humans that we haven't designed for before with our OEMs. And so I think the light bulb moments started to fall for people around the need to bring together particularly robotics and autonomy. Every mission that goes to the moon or Mars, right now is all without people. It's all designed to operate without people, with data feeds that enable the decision making at the right pace. But it's all in a GPS denied environment. So why not take that to design, a smarter comms infrastructure, a smarter infrastructure that enables multiple different pieces of equipment to talk to each other, and ultimately into the future. For the lunar surface, it will be about astronauts and it will be about equipment. In the deep mines, we'll still have a transition phase where we need to be able to find a safe operation where you can operate between people and machine, and then different, technology providers underground. So yeah, I guess it's just starting to articulate this deep underground mining environment in a way that it wouldn't really matter in many respects whether you're talking about that deep mine or lunar environment. Some people might not see the difference, and so why not bring together the capabilities, which is the hardest thing. It's about bringing together a diverse skill set and actually leveraging that skill set in that future design.
You've championed space STEM programs like the Milo Mission Academy in partnership with the Arizona State University, and have described the STEM outreach for the Lunar Rover as one of the most inspirational parts of the project. In a world brimming with diverse career opportunities, what is it about the combination of space exploration's aspirational allure and the tangible problem solving nature of the resource industry that you believe truly ignites the imagination of students or professionals?
Yeah, and I think we all know that we need more students studying STEM, and there are many different roles that people don't either see into the future. Just say people want to be an engineer, they don't fully appreciate the different subjects that you need to do, or if you want to study at TAFE and then think about what your future career might be, or if you just want to kind of build on the ground experience. We recognise that the space is inspiring. People get inspired around, robotics, automation and space. Many people don't kind of see that the opportunity is also here in Australia to participate in this industry, but also that there are industry, opportunities overseas for people to get involved in. So taking the ability to inspire people because of a space mission like the Lunar Rover, and then trying to harness that with a really strong program that accesses global expertise is kind of what our focus was. We did that for the Milo Mission Academy, which was really about supporting students 18 years old and above, both for those that were in TAFE or in university, but equally graduates that had kind of potentially thought about space, but it wasn't an industry at the time. And so wanting to have an opportunity to share this academy with them so that they could upskill around a 12-week program that would go from a requirement to, a science, need to go and discover water ice on the moon, and by designing a robotic mission to do that. So what I love about the Milo Mission Academy, it was created by Arizona State Uni in partnership with NASA. NASA wanted to make sure they had a space-ready workforce. And what better way to do that than to give people hands-on experience? And so, they've taught over 10,000 people now over the last, 5 years in design. Now, NASA actually searches for this academy and looking for their interns and their future workforce. So knowing just how strong this program was, knowing the people behind this, Jim Bell, Jim Rice, who, continue to work in supporting Mars missions and others, this program is a way to actually bring these people to the table in a virtual environment, so that people also from right around Australia could participate. I guess one of the goals from Arizona State Uni, which we certainly embedded in our mantra, was about making space accessible to all. So you do that via this virtual platform. So there are over 220 students that signed up right across Australia and a few in New Zealand as well. They had to form teams. Many of them never met through the 12 weeks, but they had to form roles. So a project manager through to the science lead, the electrical and mechanical engineers, and also STEM outreach within those programs, and then present their preliminary design of their robotic mission about the same time as we were concluding ours. at AROSE. And so we were actually able to invite some of them to our final preliminary design. What the students saw there was that the Milo Mission Academy offered something very similar to what actually happens in real life. So many of the students or grads actually realised just how much they had learnt over the 12 weeks. They learnt more about the industry over the course of that period. And we also teamed up with over half a dozen technical mentors from Australia that they were able to connect with every week. And so, many of these students have continued to do many great things through ASTRA program and different jobs that they've gained. And, they really credit some of the expertise that they gained from this academy. And then this new alumni, this new team of friends that they've built over that course. So, really, really exciting in that older age group. We also partner with Physics Education and the program that they run for robotic missions for year 5 to year 10 students as well. So it wasn't just about the older students, it was about younger as well. But very exciting to know you're inspiring people into the future careers that they may not have otherwise thought of.
Exciting. I want to linger here a little bit more. What are those crucial, perhaps even unexpected transferable skills that young people gain from designing, for example, a robotic mission to find lunar water ice? What skills that will empower them regardless of what industry they ultimately choose?
Yeah, it's a good question. And I think really when it comes down to it, while the participants were able to build a design for a robotic mission, it ultimately comes down to being able to work in a team, to have that critical reasoning and thinking behind what they do. And I think it doesn't matter what industry you go into, being able to establish a team, to work effectively within that team, to have the critical design thinking and reasoning can be transferred anywhere. And so, as I said, many of these people didn't meet each other, so they had to kind of build skills that would enable them to confidently stand into the role, to be able to work across the different people, to be able to deliver the mission. They couldn't do it on their own. It literally required very strong teamwork to do this. And so what I was really excited about at the beginning was not just to excite people that wanted to move into the space industry, but also to bring people from the resources sector, from the manufacturing sector. We had some people from the 13th Brigade and the defence sector, and technology, comms, infrastructure. So it really was a wide skill base that came in from different sectors, and those people take the skills both back out to the current sectors. Some may move into space, some may take this, including the systems engineering and design thinking, into how they approach things differently as well. There were over 30 different academic institutes that were behind the students here. So also has helped to inspire students into looking at different career pathways within those universities. So or TAFEs, huge benefit for those academic institutes as well as the students themselves.
Okay, let's delve into remote operations. Australia, particularly Western Australia, is a recognized world leader in developing those systems, managing vast, complex mining operations from control rooms thousands of kilometers away. For our audience trying to grasp the scale of the ambition, could you paint a picture of the quantum leap in innovation required to go from the already impressive remote oversight of terrestrial mines to effectively commanding assets on the moon or Mars, where communication delays are an immutable law of physics?
Yeah, and I think, actually Fulgro, who's one of the founding members of AROSE, is probably one of those great examples. And so they have a mission control centre called SPARC in Perth, which stands for Space, AI, Automation and Robotics Complex. And what they do there is take the capabilities that they've also learnt from working across the resources sector to support, many kind of remote, missions in the state, from subsea, to then take that capability into supporting lunar missions with intuitive machines, for example, and they've supported the last couple of missions there. And so, they have, knowledge of how some of the remote op centres have been set up, for the large mining companies, and they're taking that, one step further. So they, because they have both subsea and lunar and other, drone and other terrestrial missions kind of in that one centre, they're kind of bringing together capability, every day to do that. I was lucky enough at AROSE to be able to bring a couple of the resources companies into that centre at Fugro. And so it's from the insights that they gain kind of being in that centre when they start to see more specifically the lunar mission design and the opportunity that could come into their new deployment of robotic capability, either inside West Australia or outside of West Australia. There are new challenges that continue to be faced in remote operations in West Australia. I guess kind of some of the solar storm activity is just one of that, and you see organisations like Advanced Navigation who support navigation both in environment like the moon, but also in the remote environments like iron ore mining and also subsea and deep underground.
Okay, so how might developing and exploring those extreme space solutions actually boomerang back to revolutionize remote capabilities here on Earth?
Yeah, I think it's interesting when you see some of the, I guess, the people from the space industries kind of walk through the remote operating centres that we have, and they, that I guess a lot of the work that I have, as you mentioned earlier, is kind of a delay in information coming back, but also there's a lot of data and less kind of visual feeds that are used in the lunar missions compared to in the mining missions. And so, some of the things that will, boomerang back that I think and that I see will also be about how do you start to define better the data that you need for decision making into these remote ops centres? How do you establish, some of the comms infrastructure, in a different way? And I think equally, if you look at the Viper mission, and we learned about that in the mining mission to NASA Ames, they bring together, scientists and engineers. They really spend a lot of time and bringing different capabilities and skill sets together to really think about how you can both solve for the science mission, but also with the engineers and taking the next steps and where does the rover go next? How do you navigate, physically what's required while also delivering on science? And so, what I see as kind of starting to boomerang back is also how we think about exploration on Earth. Right now, or a few years ago, we didn't have Starlink, so we didn't have regular communications. We didn't have the ability to make faster or more informed decisions from remote support. So some of what we'll see more and more of coming back is just that remote operation support for faster decision making in these remote areas. I guess those are a few examples. We also had IMDEX. Who've got they call it a blast dog, but basically it's a sensor that goes down a blast hole on Earth, and they inspired many people also into how to think about the information that you need down hole and how you create decisions from that, and they're starting to also see opportunities to come back in both sensor design. How do you think forward around a new technology stack? I think one of the people from the audience there talked about innovation as integration as being the new innovation, and so more and more sense capabilities available for us on Earth. We're starting to test that in exploration environments and mining environments, but bringing that together in a single stack, just like they do in a rover on the Moon or Mars, is where people see that overlap.
Okay. The concept of technology transfer is the lifeblood of the mining space synergy you've championed. You've noted that the space industry is already disrupting what we do in mining. Could you share a compelling example of an Australian mining innovation, perhaps in robotics, AI-driven geological modeling, or harsh environment engineering that, when adopted for a space context, offered a truly game-changing solution or perspective?
Yeah, I think, Advanced Navigation is, a great example. So they've been around, a few years, and they deploy their technology for, positioning both subsea and defence, and now also in mining as well, and now kind of have been involved in a few different lunar missions. So that's kind of one great example. I guess there are a number of other emerging examples, particularly in the sensor area, that haven't been deployed yet. But you did see the collaboration between Epiroc and iSpace as well over the last couple of years, bringing together that robotics capability for excavation on the moon. So there is a small number of examples that are emerging now, and we'll continue to see more. I think there'll also be many more from space to mining.
Okay, a term our listeners will increasingly hear is ISRU, which is In Situ Resource Utilization, essentially living off the land in space. This means using local materials on the moon or Mars to produce vital supplies like water, oxygen, rocket propellant, or even construction material. The AROSE-led lunar rover tasked with collecting regolith for NASA is a direct Australian contribution to making ISRU a reality. Michelle, drawing on your extensive background in mining and mineral economics, what are the core economic arguments that make ISRU such a pivotal, almost inevitable step for the future of sustainable space exploration?
Yeah, I mean, I guess it really does all kind of come back to economics as well, doesn't it? It is about, ensuring that you don't have to continue to bring materials and products from Earth, that you can build everything that you need on that lunar environment, which, is exciting and challenging at the same time. And, people like Jerry Sanders from NASA always talk about one person's waste being the next person's ore. And so, in situ resource utilization is really about, extracting, finding water, ice, and extracting oxygen, as a energy source for rocket fuel, for living. But equally, there are many other minerals of which, can be processed for other commodities. And, Blue Origin is kind of one great example. If you look at what they plan to do with building an energy infrastructure for people. What I find is really interesting also is, on Earth, we continue to be challenged by communities around getting to a much smaller footprint into the future. And so, you start to kind of, if you were to adopt the ISRU methodology, you start to think about how do we think about the waste stockpile that we may end up with from mining the valuable mineral, and how could we look at the other processes that are required to start to reduce or ultimately eliminate what this looks like. And economics kind of come into how far we go today on Earth as well. You can't eliminate everything today, but it's certainly that challenge is set and kind of being focused on by many great mining companies. Equally, ISRU helps to kind of think about, is there a way that we could start to extract some of the lower quality resources on Earth by taking a view of different processes. And if you look at just green steel, for example, there are many overlaps with the different technologies that are being looked at both for ISRU or processing on the moon as well as for green steel. So I think at the end of the day, there's still a lot of testing to be done. There's still a lot of work or testing to be done on Earth before, our ISRU facility is on the moon and doing what we want that to do before, the full economic value chain can be satisfied to truly enable sustainable presence on the moon. But that's why I think even if there was a physical or virtual test environment set up for the sectors to work on together, maybe that could be the catalyst to accelerate, how we get to that future vision on the moon and on Earth as well.
Okay, and from your vantage point, being there in the same room with the industry and with the agencies, what are one or two most significant hurdles, be they technological, the sheer cost of those first of a kind systems, or even establishing the resource viability of world, that we must overcome to transition ISRU from a demonstration to a element of an off-world economy?
I think, there's a lot of science required to design these facilities, and then a big move then to shift these facilities to the moon. I think thinking about the future scale that we need to have on the moon requires both thinking around both the technology and achieving the right TRL to go there, but also to be able to think about the scale that we need to move towards. And hence I kind of think there are, amazing scientists, right across NASA and other commercial space companies that have been working on this for many years. And so, I would hope to see that part of the catalyst could be this overlap of capabilities from the resources sector being part of just that end-to-end design, almost a peer review from a different sector. This may not be the catalyst to rapidly accelerate the deployment of this technology on the moon, but certainly, as we talked about, both that virtual and physical. So the virtual and physical test environments could be part of that catalyst in coming together, because there is also, many trade-offs that need to be made to ultimately look at where is the ore body, where is the processing unit, where is the end customer, and so where are the different kind of locations that this could coexist together to meet the that final customer demand. So yeah, a lot of learning that we have right on Earth today as well. If you look at decarbonisation, and so how we solve for that is also disrupting supply chains. So no longer do we need to have necessarily a refinery in one location in the globe, and which is where there is low energy like hydropower or some other, and mining of that valuable resource in another place, with increasing ability to have renewable energy and long duration battery storage in the same location. You're disrupting that supply chain. We're already rethinking what we do on Earth, and so these are some of the key things that could be contributed to the ISRU design and acceleration of deployment. One other really interesting person I was lucky enough to meet at NASA Ames is Lynn Rothschild, and she's been working for a long time on extracting minerals on Mars. And so when you start to think about some of the capabilities that she's testing for future presence on Mars, there's a lot that I think can be deployed directly into how we solve for some of the tailings challenges on Earth. So whether it's about creating more stability in tailings dams, or whether it's actually about extracting the metals from these old tailings dams, creating geopolymers and being able to satisfy construction environment as well as minerals. There's a lot of other thinking as well, which is kind of in that downstream area from the ISRU processing.
We hear about a potential $1 trillion off-world economy, asteroid mining, and in space manufacturing. But this exciting frontier also brings with it profound questions about governance, sustainability, and ethics. You've personally spoken about the need for nations to collaborate, share best practices, and establish guidelines for ethical conduct, drawing parallels with the mining sector's own ongoing journey towards greater sustainability. What are the one or two most critical principles or international frameworks you believe we must urgently establish now to ensure this final frontier is developed responsibly, equitably, and sustainably, learning from and perhaps avoiding some of the historical pitfalls of resources exploitation on our own planet?
Yeah, it's a large question and a challenging question, I think, at the same time. There are many, I guess, new policies and thinking that we continue to evolve and mature on Earth, to both think about the impact that we have on the Earth, on the communities around us, on our stakeholders, and so we continue to mature with the operations that we have in remote regions in Australia and around the globe, and we continue to try to improve the practices that we have. And so, I think one of the more fundamental things is that should be established is to continue to mature what we do on Earth by how we learn from the space community. We will continue to be challenged by what we do through, I guess, ethics and the way that we think about the footprint that we leave on the lunar surface or any other planetary body, as well as the footprint that we leave here on Earth. And I think having more thinking around this, and that thinking and capability expertise kind of being built into the frameworks, hopefully will enable, the best outcome. We've operated in two quite different environments, for many decades. And so if we were to really achieve the sustainable industries that we both want, there's going to be an increasing overlap in technology, but also in the frameworks that we put in place. So I think there are lots of sensitivities around this topic. And so, yeah, the main thing is the maturity that we have is continuing to grow on Earth, and no one wants to leave a larger footprint than what should be there. And that is really our focus, whether it's about finding different mining methods on Earth to still extract the valuable materials that we absolutely need in the energy transition, but also, the footprint that we leave on the Moon or Mars is also very important, as well as that space in between.
Yeah,
and so that's the opportunity.
Okay. Michelle, your career is a powerful illustration of building bridges between deeply established Earth industries and the very edge of future space industries. Being named the 2023 Space Professional of the Year and also recognized in the top 100 global inspirational women in mining speaks volumes about the impact you've made across these diverse yet converging domains. For many students and young professionals in our audience today, what is your single most resonant piece of advice for them to navigate their own, perhaps unconventional career paths and to make their own meaningful contributions to these incredibly exciting, rapidly evolving frontiers?
Yeah, it's hard to pick that one thing, but I think throughout my career, I've continued to learn right throughout my career, continue to be curious, and continue to want to kind of really create change. And I think having the fundamental principles behind what you do, and is kind of that start point. But equally, kind of follow what you're passionate about as well. And so when I finished university, there wasn't a space industry that looks anything like what the industry looks like today. I never thought about joining the industry, but continuing to see. To get more involved in creating change in mining industry, knowing that we could make a different impact in what we do, and exploring different capabilities, exploring diverse skill sets to achieve that is probably what has led me to where I am now. And so I think it's not about joining the space industry or the mining industry. You can move between the two of them, and I think if you can take the best of each to the other sector and kind of find that overlap. I always find that working at that interface or that intersection of any industry or set of capabilities is really where value is maximised, both for your own personal growth and outcome, but also for what you might be trying to achieve in the industry. So don't think about one path or another. That intersection is also a very powerful place to be, and knowing the value that you bring to the intersection is also very, very powerful.
Okay. Looking ahead 30 years, let's say 2055, what's your vision of an off Earth, fully operational mining activity? And what key breakthroughs absolutely need to happen to make that vision a reality?
I mean, that's a long way away. And if you kind of think, if you based on everything, I hear from NASA and others around what everyone wants to achieve, I would absolutely hope we do have some kind of more sustainable presence both on the lunar surface and more activity on Mars, which is really about continuing human exploration. Really, it's not about bringing materials back to Earth. It's about that continued human exploration. And I think what I think would be a success is that not only have we achieved these future presences, but we've done it through a collaboration between the sectors that we have, and there's a faster transfer back and forth. There's a faster movement of people back and forth that kind of shift between each other to bring their capability, but also kind of to bring their learning back. I personally believe that when we won't solve for the same challenges that everyone is set for 2050 around carbon emissions if we don't work together. And so if we think about what we need to achieve on Earth, then also kind of thinking about how do we get there in the space sector, I think is one of the most important catalysts to get there. And so that's why I think the NASA missions continue to grow these with more and more people, to having more specific funding associated, being with kind of new missions together, having both policy and public and private partnerships into the future will be important. Having VCs see this overlap between robotics and AI across any industry is going to accelerate investment into this area. It's going to accelerate kind of more people into this area, technology development, and then hopefully that fast track to the 2055 vision of that increased presence in each of these areas. And that's kind of why I think we're in a privileged position here this year in Australia with the IAC conference being held in Sydney at the end of September. In Australia, we have many adjacent industries to the space industry. And so, we're really looking forward to being able to bring these adjacent industries to the table, to being able to forge new partnerships with people from around the globe. And so, this continued ambition of a more integrated set of capabilities is what we want to ultimately achieve through this. And it's going to be because we inspire each other and bring together our experiences and our challenges that we need to solve at that one table. And so working with the Space Industry Association of Australia in kind of leading that resources working group, this is something I'm super excited about, and would love to hear from any of the listeners if they want to get involved in this, or any ideas that they see would be compelling for the resources sector to come to the space to the space table, but also other industries. Probably one other plug in Perth directly after ISC. I'm working closely with the IEEE and Rob Mueller to be able to deliver the Robopalooza event. It's basically a vibrant kind of robot party and intended to inspire students both through STEM, but also intended to integrate industries and doing this adjacent to the Space and Earth team from My Security Media, who are running the robotics and AI event in the subsequent days in Perth as well, has the opportunity to bring together many people in Perth, both for demonstration, but also in some very inspiring talks at their conference. So a lot more to happen just in this year alone, let alone beyond. People like the Oxford Space Initiative and Carmen are also kind of really focusing through people like Laura Edwards and helping make this a reality in Australia as well.
Great. I'll make sure to put the links in the description. Perfect. Michelle, thank you for the kind words, and thank you so much for sharing your expertise and insights with us. To our listeners, join us next time on the Omar Al-Laili podcast as we continue to explore the science, technology, and engineering that advances space exploration. Until then, keep exploring.